Hello all, welcome back to my channel. This is Sushil, your host. So today's module, we are going to continue with the topic electric charges and field, and we are going to learn a very important concept, my dear students. That is nothing but the properties of charges. Yeah, this is a very important question, and this question is basically asked for 2 marks or 3 marks in the annual exam. And if you ask me today, I will give you an assurance that in the coming exams, in the coming exams, whenever you have your college level exam, this question is surely gonna come in your paper. It's a guarantee. This question that is mentioned the basic properties of charges is 100% going to come in your question paper for either 2 marks or maybe for 3 marks. Keep that in mind. Yeah. So let's understand what are the basic properties of charges. Yeah. So we have the properties of charges. So let's understand. So the first property of charge, there are basically two kinds of charges what we have already studied. One is positive and the other one is negative. We have also studied that like charges repel and unlike charges, I can get that answer. Yes, unlike charges attract. So you can see that I have a positive charge and a positive charge. So the meaning of repel is nothing but they are just going away from one another. So you can just see how they're moving away from each other. So basically like charges repel. So positive and positive, they are like charges and they repel each other. Next, we have a negative charge and a negative charge, and you can see now what is happening between them. So again, like charges repel each other. And we also studied that unlike charges attract. So now if you observe positive and negative, yeah, positive and negative. So positive charge and a negative charge, they are basically unlike charges, and unlike charges basically attract each other. So I hope you are clear with these two properties. And we have also studied that electric charge is basically a scalar quantity. Yeah, electric charge is a scalar quantity. Now, what do you mean by scalar quantity? Please understand the physical quantity which has got only magnitude but no direction is called as scalar quantity. So a small recap of your PU1 concept, scalars and vectors. So I hope you're clear with the concept called as scalar quantity. So any physical quantity that has got only magnitude but no direction is called as a scalar quantity. And I hope you're clear with the word physical quantity. Any quantity that can be measured and expressed in terms of a numerical value is called as physical quantity. So I've given you some extra knowledge, extra concepts so that you people understand it. Yeah. So let's go with the next one. So now comes the basic properties of charges. Please understand students, this is very important and this concept is very simple. So the first one is charge is quantized. Now what do you mean by this? We also call this property as quantization of charge. Now according to this, please understand all free charges, all free charges are integral multiple of a basic unit of charge. I repeat, all the free charges are integral multiple of a basic unit of charge denoted by E. Yeah, denoted by E. Now, what does this E stands for? It stands for the charge of an electron. Okay, so please understand the charge Q on a body is always given by a formula Q is equal to NE. Please understand. The charge on a body is always given by a formula Q is equal to NE, where N is a positive or negative integer. I repeat once again, the formula for quantization of charge is given by Q is equal to NE, where N stands for either a positive or negative integer. I hope you guys are understanding this. So the value of E is nothing but 1.602 into 10 power minus 19 coulomb, where coulomb is nothing but the SI unit of charge. Yeah, please understand students, the charge on an electron is given by minus E, whereas the charge on a proton is given by plus E. I repeat once again. So charge on an electron is minus E and charge on a proton is plus E. Yeah. Okay. So to add on few more things, please understand. In simple words, the smallest amount of charge that can be added or removed from a body is nothing but 1.602 into 10 power minus 19 coulomb. I repeat once again, the smallest amount of charge that can be either added or removed from a body is nothing but 1.6 into 10 power minus 19 coulomb. Yeah, and to give you some extra information, the quantization of charge was first suggested by Faraday, yeah, and then it was experimentally demonstrated by Millikan. So if you check out in YouTube, you have some experiments of Millikan, and you will enjoy those things. So please, if you find time, check in YouTube about Millikan's experiment. Yeah. So I hope you're clear with the concept of quantization of charge. So in simple words, Q is equal to NE, where N stands for either a positive or negative integer, and E is the charge of the electron. So let's move ahead with the next property. The next property is nothing but charge is conserved, or we can also say it is conservation of charge. Now, you must have studied conservation of energy, conservation of mass, and if we use our smartness, we can also define now conservation of charge. So what is conservation of charge? The total charge of the isolated system is always conserved. Please understand. In some simple words, it is not possible to create or destroy net charge carried by an isolated system. So you can see that in an isolated system, the total electric charge is always conserved. Yeah, you cannot either create a charge or you cannot destroy a charge, but it can just be transferred from one body to another. So that's a very simple property. So moving ahead to the last one, that is called as charges is additive, or we can also call it as additivity of charges. Now, what are additivity of charges? Listen to this. Listen to this. If a system contains a number of point charges, please understand. If a system contains a number of point charges, the total charge of the system is the algebraic sum of all the charges present in the system. I repeat, the total charge of the system is the algebraic sum of all the charges present in the system. And this is called as additivity of charge. So you can see now, here that charges can be added by the rules of algebraic addition. So let's see one example. Let's take one example. So we have a system here. So you can see that the system has got plus 2 electrons, minus 15 electrons, plus 21 electrons, and minus 3 electrons. Now, what is additivity of charge? According to additivity of charge, you can find out the net charge of the system by adding them. So if I'm not wrong, I think the answer will be here as plus 5 electron. So let's check it out. So plus 2e plus minus 15e plus 21e plus minus 3. So as I said, the answer is plus 5 electron. So these are the very, very important three properties of charges. So let's have a quick recap. So the first property is nothing but, you can say, quantization of charge. The second property is conservation of charge. And the third property is additivity of charge. Please understand, students, they ask this question in a very tricky way. If they just ask you, mention the properties of charges, please understand that you just write on the side headings. That's it. And in case they ask you explain, then you have to just explain whatever I've given it to you. Yeah. So please make a note of it. Please put a star mark. I'm very much sure that this is a 2-star question or a 3-star question, which is surely going to come in your coming exams. So thank you so much. I hope we guys are clear with this concept, that is the properties of charges. Please do like the video, do subscribe my channel, and please share it with your friends. Thank you so much. Have a great time. Happy learning and stay safe, stay home. Thank you.